Let f of x be x squared e to the x. Show that f dashed x is x e to the x, x plus 2. Well, what we have here is a product. So u is x squared, v is e to the x. du dx then is going to be 2x, and dv dx would be e to the x. So f dashed x would be v du dx, so that's 2x e to the x, plus u dv dx, which is x squared e to the x. And therefore we can take out an x e to the x, open a bracket, and if we're taking out x e to the x, we're left with 2 plus x. Use calculus to determine all the stationary points of f of x and determine their nature. Well, we know that we need f dashed x to be equal to 0. First thing I'm going to note is the number of marks here. We've actually got to do this. We can't just use the cas. So f dashed x is 0, means x e to the x 2 plus x is equal to 0. So the x term tells me that x could be 0. And the 2 plus x term tells me that x could be negative 2. And of course, e to the x can never be 0. So it's just those two. Now, f of x is given here. If x is 0, that's 0. So the coordinates here would be 0, 0. And if x is negative 2, that's going to be 4e to the negative 2. So I'm going to say negative 2, 4e to the negative 2. Now, in order to investigate the nature, I'm going to need the second differential. And what I'm going to do here is I'm just going to put the x back into this bracket. So I'm going to consider that f dashed x is e to the x, 2x plus x squared. I think that will make it a bit easier. Again, it's a product. U is e to the x, v is 2x plus x squared. So du dx is e to the x, and dv dx is equal to 2 plus 2x. So our second differential is v du dx, so that's e to the x into 2x plus x squared, plus u dv dx, which is e to the x into 2 plus 2x. And we can put all of that together as e to the x into x squared plus 4x plus 2. F double dashed 0, well, e to the 0 is 1, and the bracket will become 2, so it's just 1 times 2, and that's a positive, and that implies that we have a minimum at 0, 0, and then f double dashed of negative 2 would be e to the negative 2, which is still positive, into 4, take 8 plus 2, which is negative 2e to the negative 2, which is negative, and that implies a maximum at negative 2, 4e to the negative 2. Determine the coordinates of any points of inflection. Now it's just 2 marks. We have the second differential above, But I'm thinking here that we might be best off just using the CAS. So let's go graph and table, clear anything we've got, and input our new function, which is x squared e to the x. Okay, and let's graph that function. I might just try to get a better window on it. So let's maybe go just to 5 here. And it seemed to go a lot of it off the top of the screen, so let's do something like that. Okay, so let's see if we find any inflection points here. So we've got the one there at negative 3.41 and 0.38. And I think there's going to be another one on this section sort of over here. And negative 0.59. I'll make it 586 there. And 0.191. So we're told, hence sketch the graph of y equals f of x, clearly indicating the location of all stationary points and points of inflection. Well, it appears there's not much going on below the axis. And what I might do here to assist me, since there's 4 marks, they're going to expect reasonable accuracy, is let's go back here and instead of generating the graph, let's generate a table of values. And we'll take that table from negative 5 to 5. And so what do we have? Well, 0, 0 is an easy point to put on there. We also know that that 0, 0 was a minimum. So let's just make a note that that is our minimum. And negative 2 is about 0.5413. So it's probably about there. And we know that that was our max. And that was at negative 2. And 4e to the negative 2. So we know that's a max. And let's see what happens on this side. 1 is 2.7. So that's 2, 4, 6, so about there. And 2 might have disappeared off the graph altogether. It has indeed. So we know that this is going very steeply up here and is going to shoot off the top of the screen. Now here we know that that one is a minimum. Let's just get the graph back. So let's go here, let's graph it, and we can see that it comes up there, like so, and it's going to go very sharply off the side of the screen. Again, I'm just going to get the table back, and this is 0.16, so it's going to be somewhere in that first square by the time it gets to here. So it's going to do that. And we know that there was a point of inflection around here. And haven't got it quite high enough, but it will do for now. Negative 3.41, 0.38. And then there was another one, negative 0.58, so about negative 0.6, 3 squares across, and negative 0.191. That's a bit too high. Let's bring that down. So about there. And negative let's call it 5.9 and 0.19.